Hi, I'm Miss Wong. Let's look at factorizing using the cross method. Last time in the video we looked at expanding and then how to factorize, working backwards, looking for patterns, and we used the grouping method. Today we're going to use the cross method, which is my favorite method to factorize. Let's see how it works. We can move these two factors and put them directly underneath here. And recall that what we do when we factorize is getting this expanded form, and we're trying to get these two factors. Now, what patterns can we see when we put the two factors directly underneath it? Well, we can see that the 10x comes from the 6x plus the 4x. And we can see these two arrows match these arrows over here. Double check. That gives us 6x. That gives us 4x. 6 plus 4 is 10x. And we also notice something else. We notice that the 3 times x gives us 3x squared and the 4 times 2 gives us 8. They're matching our expanding arrows, but they're directly underneath it, so it's easiest for us to think about. So let's try this. How do we go from here, the 3x squared plus 10x plus 8, into these two factors? So let's do this. What times what is 3x squared? We could say x times 3x. Then we would say what times what is 8? We could say 4 times 2. But we notice that when we do that cross, so 4 times 3x is 12x, 2 times x is 2x, 12 plus 2, 14, not 10. So 4 and 2 aren't the values we want. We try two different factors, maybe 2 and 4, switch them around. Let's try it again. 4x plus 2 times 3 is 6. So 6x plus the 4x is 10. So that's the two values that we want. And then to factorize, we just put the brackets on top and bottom. So now we have x plus 2 for the top and 3x plus 4 for the bottom factor. See, like we did before. And that's factorized using the cross method. So to recap, we look for values underneath the terms that multiply to give us that. And then for the cross, multiply, 3 times 2 is 6x, multiply, 4 times x is 4x, and then add these two. 6 plus 4 is 10. Let's try it again with a different question. So what two values gives us 2x squared? You might say 2x times x. What two values give us 15? We can guess, for example, 1 times 15. But we can clearly see that from the cross that it won't work because 2 times 15 is 30, and then 30 and 1 doesn't give us 11. So we'll try two different values, maybe 3 and 5. And then we can see that 2 times 5 is 10. Then 3x, well, 10 and 3x is 13x. Getting closer, but not quite 11. So we could swap them around. Maybe we can do 5 and 3. So now we have 2 times 3 is 6, and then 5. 6 plus 5 is 11. So then we bracket it off and we just have to copy it down. So 2x plus 5 and then the x plus 3. And that's the factorized form. You can check by expanding to see that we get back to that over there. Sometimes I've called this as the chopstick method because if you picture the cross as chopsticks, you're picking it up and adding them together to give you the middle value. Let's try another question. 3x squared plus 17x plus 20. Think of what times what gives us 3x squared. 3x times x. Doesn't matter which order you put them in. Now 20, what times what gives us 20? Well, we could guess 10 times 2, but then does that give us 17? 3x times 2 is 6, and then 10 times x is 10. 6 plus 10 does not give us 17. So that's not it. What about 4 times 5, you might guess? Well, 3 times 5 is 15. 15 plus 4 is way too much, not 17. Maybe we can flip them. What about 5 and 4? So 4 times 3 is 12. and then 5. 12 plus 5 is 17. So that's the correct order. So now we bracket it off, and we have 3x plus 5 is our first factor and x plus 4 as our second factor. One more. This time we have 12x squared and the 2. Now, the 2 is easier because there's not many combinations, it's just 1 and 2. The 12 is trickier because there are more factors. So I'm going to put the 1 and 2 first, and now I'm going to start guessing what works for the 12x squared. So we could do 12x times x, for instance, but that's way too much because 12 times 2 is 24, and then 1 times x is 1, 24, and 1 is not going to give us 11. So we need different factors. What about 6 and 2? Now 6 times 2 is 12, and then 1 and 2 is 2. It's getting closer, but not quite 11, because that's 12 plus 2 is 14. What about 4 times 3? 4 times 3 is 12. Right, so 4 times 2 gives us 8, and the other line, 3, 8 plus 3 is 11. So those are our factors. Now do bear in mind, I was giving you an example of numbers I would have guessed. You might have guessed 4 and 3 in your first shot and then gotten the answer straight away. So stop whenever you get the values that work. Another example. So 2x and x give us 2x squared. One numbers give us 15. We could try 15 and 1, but 15 minus 2 does not give us 7. So cross it out, and it's nice to keep the values that don't work on paper so that you know which numbers you've tried. What else can we try? 5 and 3. So 2 times minus 3 is minus 6. Plus 5 doesn't quite work either. What about if we swap them around? So 5 times 2 is 10. Minus 3 is 7. So we found our factors. The last bit is easy. Just bracket it, copy it out, the first line and the second line. Next question. Again, it's very similar, but this time the negative is in the middle. So 2x and x would be our first two values over there. Now we have to think of 15. We could think of minus 5 and 3. We'll swap them around, let's see. So 2 times 3 is 6, and then minus 5 is way too little, so that's not it. Maybe we move the negative to the other value, or switch them around. Minus 5 times 2 is minus 10, and then 3 times x is 3, minus 10, and 3 is minus 7. So those are our factors. Have a go at these again. So copy just the question and see if you can get the same answer. Here are another 4 examples. Try this and then unpause to see the solution. I won't go through the methods, it's going to take me a little while, but here are the answers. And don't forget, you can always check by expanding to see if you got the right answer. Practice, practice, practice. It's a pretty tricky video. Comment down below, tell me how you're going, and I'll see you next time. Bye, thank you for watching.